A velocity selector is set up with an electric field of 126 newtons per meter that is pointing up and a magnetic field of 3.02 times 10 to the negative 1 Tesla that is directed out of the screen. What velocity will be selected using this setup? Remember that for the velocity selector, we need the electric force and the magnetic force to be in equilibrium. So QE, the electric force, has to be equal to QVB, the magnetic force. In order for this charge to pass through this region undeflected and make it through the other side. So if we cancel charge on each side, and we see that if we divide both sides by magnetic field, the velocity that will be selected is the ratio of electric field to magnetic field. So we have an electric field of 126 divided by a magnetic field of 3.02 times 10 to the negative 1. And we've come up with 417.2 meters per second for velocity. Okay, so any charge traveling through this region with a velocity of 417.2 will make it through undeflected. A positive charge moving below that velocity would, well, if it's moving below that velocity, the magnetic force is going to be smaller. So we could say here that the electric force is bigger than the magnetic force, and on a positive charge, the electric force is going to be up. So this object is going to be deflected upward, and it's not going to make it through our aperture on the other side. The velocity selector will select any charge that is moving with the desired velocity. So this is any charge with a velocity of 417.2. It doesn't matter if it's a positive or a negative charge. It also doesn't matter how massive the charge is. Whatever charge is moving at a velocity of 417.2 meters per second is going to go through these fields undeflected.